right, hello everyone. Today we are going to be doing another Floe tutorial, and in this one we are going to be talking about programming ESP32s and what that entails. So in this video we will be featuring Tobor, and we will be looking into the code that makes the pen plotting version of this robot go. And so without any further ado, let's just get started and hop right in. On the left-hand side here, you can see the canvas that is actually the program that is running on the robot itself. And over on the right here, you can see that we have a web page that is actually running on Tobor itself. And everything that you have over on the left here that is going to be featured in the GUI is going to show up by the GUI just by being present on the left. So let's go ahead and look a little bit deeper in here, and we are going to start with this PWM object here. So with this, we have a whole bunch of different, hardware objects or, different kind of elements that can be on an ESP32, and you can just drag those into the canvas and wire them up a little bit. You can see if we open this up, that is going to want a pin. And, so just like any other kind of PWM object, we have a duty and a frequency. So a lot of these objects should feel pretty familiar to people who are used to playing with these kinds of devices. So again, we have a PWM object. And with this PWM object, we are going to be just manipulating this little hobby servo here. And excuse me, let's go ahead and just start playing with it. So let's close some of these things we don't need. Again, let's look back here. We have a slider, which is going to set the duty. And we also have a little checkbox here. This checkbox is going to go through a little code block that is going to modify it just to values that are going to be useful for the slider. So let's just play with that real quick. And you can see here that when we check and uncheck this checkbox, that we get the pen to move up and down. So let's go ahead and kind of dive a little bit deeper into what that actually means. So again, this is a hobby servo object. And with those, and anybody who's familiar with these, you're going to have a minimum PWM value and a maximum PWM value. And so these are mapped here with this 0.06 and 0.15. And again, we also have a slider here. And with this slider, we can set any kind of arbitrary values that we want inside here to have this servo move however we see fit. As we go back here, again, we have a little code block here. You can see that everything here is event-based. So this checkbox here is going to send out a true or false, depending on if it is checked or unchecked. And we are going to send it into this little function. If it is true, we are going to send 0. If it is false, we're going to return a 1. And again, those are going to be fed into this slider. And this duty is mapped to values from 0 to 1. So a 0, we will have this 0.06, and a 1, we'll have this 0.15. So let's go ahead and look at some of these objects here. So we have this pen position object. And sorry about that. And you can see here that we have this GUI slider object called pen position. So just like any of the other parameters, we can go ahead and give it a value. So let's go ahead and set this to half. And you can see here that as soon as I press enter, the slider itself has moved to half, and the servo has also moved. Let's go ahead and give it another value so that we can go ahead and see this. And you can see that it's moved up here. So let's go ahead and look a little bit deeper into this pen object itself. So this pen is the PWM object itself. And anybody else who is used to writing in Python or MicroPython will be familiar with just having duty on one of these objects. And you can see here that when we ask for the property of duty, we are actually getting this GUI slider object. And you can see here, if we go back to pen position, you can see here that these are actually the same exact objects. So again, you know, if you wanted to go ahead and you are manipulating this object in kind of a CNC type program, or you're doing something, you know, a little bit more robotic or something where you're programmatically trying to manipulate this PWM object, you can use it just like you normally would, with the addition of easily being able to have a value set here in some kind of GUI object like a slider or some other kind of value. So again, let's go upstream a little bit more here. Again, we have this checkbox, true or false. It is going to send down into a 0 or 1 to the slider. And again, the 0 or 1 is going to be mapped to here. So let's go ahead and look back here, and you can see that behind this checkbox, we actually have another object. So let's go over here and look. You can see here that this is going to go into this digital input. And that is going to be this button right here. So let me go ahead and push that, and you can see here that when I push and release this button, that not only is the servo going up and down, but the checkbox is also going checking and unchecking. And this GUI slider is also going through its values. So again, this is all event-based, and you can tell we push the button, true would come through here. It's going to get our checkbox. It's going to go through, down and down we go through all the objects. So again, this is super easy to, you know, create and manipulate these objects with extreme ease. So let's go ahead and we're going to turn down the lights a little bit, and we are going to look into the NeoPixel objects and go a little bit deeper there. Actually, before we do that, let's go over a little bit of what the hardware is that we have here. So again, we have obviously our PWM object is going to go to this little servo header that we have here. So we have a little 5-volt and servo header output here. We have an ESP32. This ESP32 is going to be running MicroPython. This is just a regular old ESP32. And we have an SD card on here. We have another ESP32 here. This is going to be running Fluid NC, which is a stepper motor type piece of hardware that is going to be the thing that actually does the path planning and whatnot when we're moving the arm around and actually physically moving the stepper motors themselves. We have a bunch of stepper motor drivers and some extra outputs and various power conditioning and power conversion. We also have a couple of encoders here. So we have some magnetic encoders, and let's go ahead and take a look at those real quick. So we have, here they are. So we have theta encoder, and let's go ahead and look at theta encoder. And you can see that we have an object here. And again, you know, this is going to have a state. And that is the angle of the shoulder joint. So let's go ahead and move this a little bit. We'll go ahead and do that again. And you can see here that we are getting the values for the joint angles. And again, these objects here are going into this gerbil object here. And you can see that gerbil Scara is getting these encoders here. And so when we open up the GUI for that, you can see that we are actually live feeding our encoder values to our front end here. And again, very simple, very easy. Again, this is just over I2C. We have an I2C bus right here that we've set up on a couple pins. So again, very simple, very easy to use. Let's go ahead and we are going to now turn down the lights a little bit, and we will look at our NeoPixel object and go a little bit deeper into, how some of these other complex objects work. So we will be right back. Okay, so we're back here, and we are going to be looking at the NeoPixel object. So let's go ahead and take a look at what we have here. Let's zoom in a tiny bit. You can see here that we have a few ports on the side here. We have delay, and that's going to go to a GUI slider called animation speed. You can see that we have that over here. We also have another slider here that is going to be choosing the animation and is going to be choosing between off, rainbow, and color chase. We have some more animations that are coming, but these are the two that we have at the moment. So let's go ahead and start manipulating some of these. So we have the animation speed, and you can see here that this is going to be a delay. So let's go ahead and turn this way down. And you can see now that these 8 NeoPixel objects up here that are part of this NeoPixel. Let's go ahead and take a look in here. You can see that it is on pin 15, and there are 8 pixels. So anybody that's used to setting up and working with NeoPixels should be able to pick this up pretty quickly. Again, we have an animation speed slider here. Let's go ahead and turn it way back down again, and let's go ahead and turn this animation up here, and you can see now that we are doing this color chase. So again, just like everything else, we can take a look at this object here. We have our NeoPixel object. We have our animation. And you can see that that is the GUI slider object that is right here. We can also go ahead and take a look at what its state is. Its state is 2. How about we go ahead and make this guy 1? So we'll go ahead and we will call it. And you can see now that we have gone back to the rainbow. Again, to look into this GUI slider a little bit here, this one we have the output float turned off. And we also are going to be mapping from 0, which is the default value here. So if we right click on one of these ports, we can see that the default value is 0. So we have nothing there. And we are going to 2. And then also with our animation speed, we are going anywhere from 10 milliseconds to 185 milliseconds respectively. So again, it's very easy to set these up. Let's go ahead and turn this off. So why don't we go here and 0. So now we have turned this off. And if we go ahead and take a look at this code here real quick, I'll double click on that. We can view code. And you can see here that let's look for our call method. So here, if we call, is going to accept a color. So let's go ahead and send a color in. Let's go ahead and it is going to want a byte array or a tuple. So let's go ahead and send in a tuple. So let's make it kind of a green-blue color. So we will have no red. We will send in, how about 5 green and 4 blue. And you can see now that we have set all of the colors to the color that we have just sent. Now, also keep in mind, that inside of this object, we actually have, a regular NeoPixel object. So when you're going and creating other things, you can go ahead and you can see here that we have a genuine NeoPixel object here. And if we were to set some color for, let's see here, let's do the first pixel, which I believe is this one right here. So we will go ahead and I believe that this is the notation. Let's turn this one a red color. So let's go ahead and 300. So we have set the first pixel to red, but again, we need to tell it to right and actually write all the values there. And you can see now that we have actually turned that particular pixel to red. So that's going to bring us to our next step here, which is to look at some of these animations. And again, we will be coming out with quite a few of these, so you won't have to worry about making them. But this is just an illustration of, how a bunch of this is created and, how easy it is to go ahead and manipulate these things. So again, this is actually the code for the rainbow, and we are actually, passing in the NeoPixel object itself and whatever index our animation is supposed to be at. We will go ahead and that's going to be handled by the greater NeoPixel object that we have on the outside here. We'll handle the index and hold on to the NeoPixel object, and we're just passing in and saying, hey, give us some values to send, and then we are going to actually, tell it to write. So another thing to keep in mind here, you can see here that, let's go ahead and we will look at our animations. And you can see here that we have a list, and we have rainbow and color chase. So keep in mind that when you have something that is a list, the compiler will set the order based on which one is on top. So because the rainbow was on top, it will put that one first. So just keep that in mind if you're doing something in the future, that the Y value is going to determine which things come first. Again, as we kind of like go deeper down inside of this, let's go ahead and change this back to the color chase. And you can see this going around, and you can see that there is a fill color and a dot color. And these are going to be wanting a RGB type. So let's go ahead again, and we can either get to this color chase object by actually typing in color chase, or we can just create a new variable here, animations, and this is going to be the second element in the list, so it is going to be 1. And you can see here that again, this is just vanilla Python, and we don't really have to worry about much. And anybody who's used to Python should be able to just drop right in here and start programming. And while these boxes and lines may seem a little bit intimidating at first, it's pretty intuitive and allows you to do some pretty complex things here. We're setting up quite a bit with not a whole lot going on here. So again, we have the dot color here. So let's go ahead and change that one to red or something, let's say. So again, dot color. And you can see here that we have an object. So let's go ahead and we can go ahead and give that guy a tuple for this. So let's go ahead 3, 0, 0. And you can see now that the dot going around is in fact red. So again, very simple. Everything here is made to just be about as easy as it can be. Let's go ahead and quickly take a look up in the corner here. We have this ESP32 core and our SD card. So again, we have an SD card here, and we are running an ESP32. Let's go ahead and just kind of take a look in here. And we don't really have a whole lot going just yet, but handling the Wi-Fi is something that is unique to the ESP32. And so when Iris is like, hey, start up your network, the ESP32 core will be able to handle that. and go through various boot and other methods that we have here. We also have a few standard buttons that are specific to the hardware. We have this particular NeoPixel here, which is going to track the color, or I'm sorry, it's going to notify you based on different things. So as it's connecting through Wi-Fi, you will see it blink different colors. This function button, we haven't quite added the functionality in just yet, but this function button will help do some factory resets or some other kind of like you want to go ahead and do something specific on the hardware with a button. We have that as a standard option. Also, the particular bus that you have on your device, you will hook this up into the core so that everybody knows how to turn things on, and the ESP32 core can handle things itself. Because remember, even though we are running this over on this right-hand side, we are running this on the ESP32 itself. Keep in mind that you can also run these just in the browser in MicroPython, just in the browser. So you can see here that like over on the right, we have this blinking heartbeat light, and everything is going here, while this one over here is dead because there actually is no hardware. But you can go ahead and manipulate these objects. You can look at various different things. You can see that as we manipulate this object, there is no servo attached to this, but you can see that as we are changing the checkbox, that we are actually manipulating the slider itself as well. So this is a really good and powerful debugging tool that you can iterate quickly and just run and test and prove things in the browser before you take the time to actually load it onto your device and wait to see if it works or fails over there. I believe that this is a pretty good overview. We will be going over probably some of this more specific robot controller stuff in another video, but I think that this is a pretty good exercise that we did right here. This is a basic overview for code on the ESP32. Again, we have all kinds of different modules that you can use on the ESP32s. We are adding more all the time. We also have various hardware peripherals. We have the encoders or a QR code reader, different scales, or output expanders, RFID. There are a whole host of various parameters that can be used for many different applications and devices. And allowing other people to actually create some of these parameters is something that we are really excited to be having come out in the near future as well. After reviewing the video, I noticed there was a little piece that we missed that's important. If you want to go ahead and load this program onto an ESP32, you're going to have MicroPython on your microcontroller. And we have a repo here. We'll share the links and everything to this. But if you want to use CAN bus, you're going to have to use one of our compiled versions. And if you aren't using CAN bus, you can go ahead and use any of the modern versions. But what you're going to want to do here is, after you've programmed everything here, again, you can run it in the browser by running with MicroPython with PyScript. And you can see here that we have it running. If you want to go ahead and load that onto a ESP32, you're going to want to hit View Code here. And you can see here that we have the code, and here's a bit of Python that's going to be kind of the config that is going to be running on it. This is the main function that's kind of called to actually go ahead and build everything. But what you're going to want to do is up here, there's this download zip. So we'll go ahead and we'll press that. And let's go ahead and look at what's inside of there. There is a whole list of Python files, and you can see also that this reflects all of the dependencies that were created when we dragged everything out. So again, very easy. And we really look forward to seeing what you guys do. Please send us some questions, comments, concerns, and we'll see you next time. So again, I would like to thank you for your time. Please let us know if you have any questions or comments or anything, and we'll see you the next time. Thank you so much.